guys, questions on the homework assignment? All right. So we're going to continue on with the note sheet from yesterday, 3.6. So we're going to be solving quadratic equations using the quadratic formula. And for us to be able to use the quadratic formula, we do need the equation, the quadratic equation, equal to 0. So looking at this here, what do we need to do to get this equation equal to 0? Which one do we want to move? The 5x? We can move the 5x squared. We can subtract it from both sides. Because negative 5x squared plus x plus 8 is equal to 0. Because we want to put it... Yep, that one right there. Yeah. Yeah, just went one too many. Yeah, it took me a second too. Ax squared plus bx plus c is equal to 0. So looking at this here, what's the value of a? It is 5, but it would be what? Negative 5. The value of b, number in front of x is 1, and c is 8. We'll do several. So, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'd have negative b. Well, our b value is 1. Plus or minus the square root of b squared minus 4 times a, which is negative 5, times c, which is 8. All over 2a, 2 times negative 5. Now at this point here, we can go on and simplify. So we have negative 1, which is, well, negative 1. 2 times negative 5 is negative 10. Okay, guys. Now at this point here, we need to do everything or simplify what's inside the square root. Our 1 squared minus 4 times negative 5 times 8. One squared minus 4 times negative 5 times 8 is 161. Now we do need to see if we can take square root of 161. See if that simplifies at all. And it does not. So questions on this so far? Now the last thing we want to do or need to do is we need to get this negative out of the bottom of the fraction. I don't want to leave a negative in the bottom. So what we're going to do is we're going to take this negative 1, and distribute it through the top. Doing this does make the 10 on bottom positive, but it's going to change all the signs on top. So the negative 1 is going to go from negative 1 to positive 1. Okay. Now we do have the square root of 161, yes? So we have the plus or minus. So the plus and the plus or minus is going to become negative. And the negative is going to become positive. Because I is the square root of negative 1. Yep, so it just stays the same because the plus becomes minus, the minus becomes plus, because all we did was multiply through by negative 1. So if the negative had gone inside the square root, then yes, we would have gotten the I. Does that make sense? Yeah. I only comes when we take a negative out of the square root. Incidentally enough, if we'd have gotten the A positive, we would have gotten to this originally. Questions on this here? We ready for the next one? We're going to do 2 more of these with the quadratic formula, and then look at the discriminant. So this here, we have 25x squared minus 8x equals 12x minus 4. We need to get this equal to 0. Right, because no matter which way we go, we're going to have to move 2 things. Either move the 25 and negative 8x, or the 12x and negative 4. If we can, I would try to keep the A, that 25, the x squared term, positive. So we can subtract 25, or 12x first, which would give us 25x squared. Negative 8x minus 12x, is going to be negative 20x, is equal to negative 4. 25x squared minus 20x plus 4 is equal to 0. It would have been nice if we did have a greatest common factor, because we could have taken it out and made it a little bit nicer to work with, but unfortunately we do not. Ax squared plus bx plus c is equal to 0. A is 25. Almost. Negative 20 and c is 4. Questions on any of this so far? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So, negative, all right guys. Let's focus in here. Negative 20 plus or minus the square root of plus or minus negative 20 squared minus 4. A is 20, positive 25. C is positive 4 all over 2 times A. Okay. Right, our negative 20 is just going to be 20. And our 2 times 25 on bottom is 50. Now we need to figure out what goes inside the radical, because we have negative 20 squared minus 4 times 25 times 4. Negative 25 squared minus 4 times 20 times 4. Wait, did I flip the 20 and 25? Yeah. Because negative 20 squared is 400. 4 times 25 is 100 times 4. Well, sorry. Negative 20 squared is 400. 4 times 25 is 100. Times 4 is 400. And when we subtract those two, we do indeed get 0. Now, what is the square root of 0? 0, because what times itself is 0? Well, that's just 0. So that tells us that at this point here we have 20 plus or minus 0 over 50. Wait a minute. What's 20 plus 0? 20, yes? 20 minus 0 is. So really all we have is what? 20 over 50. That can be simplified. So we do technically still have two solutions. One of them is 2/5 and the other is 2/5. Because with our plus or minus 0, we normally just drop it, but let's scroll back up here. Kind of what we can say that we're saying is, well, I have x is equal to 20 plus 0 over 50, which is just 20 over 50, which is 2/5. We can also say that we have 20 minus 0 over 50, which is indeed the exact same process. We still do have two solutions. They're just the same solution. Does that make sense? In most books, some books will say that we have one real solution for this type of problem. I think it's better to say we have one real unique solution. We still have two. They're just the same. They're not unique. They're not different solution. But 2/5 is the final answer. Questions on this here? All right. Negative x squared plus 4x equals 13. Right. It's better to keep the x squared positive because as we saw in the last one, we ended up having to take that negative out of the bottom. It caused issues. Well, we can either divide everything by -1 or multiply everything by -1. Because all that's going to do is change the signs. Negative x squared is going to become positive x squared. Positive 4x is going to become negative. Negative in our 13 is going to go from negative to positive. Which means a is now 1. X is equal to negative b. Would be negative 4. Plus or minus the square root of b squared. So negative 4 squared minus 4 times a, which is 1 times c, which is 13 all over 2 times 1. So negative 4 is positive 4. Plus or minus our square root here in a minute. And on the bottom, 2 times 1 is 2. Negative 4 squared minus 4 times 1 times 13. Parentheses, negative 4 squared minus 4 times 1 times 13 is negative 36. Well, we will need to see if that radical reduces. Now this is the first one we've had with the quadratic formula where there is a negative inside that radical. But so the negative would come out as I. Now what that leaves us, yes, which leaves us with the square root of 36, which indeed makes it 6I. Now this one here is one of the reasons the 30xs will not like doing this all at once because it'll throw an error with that there. Now the last question is, do the top two terms and the bottom one have a common factor? Well, there is an I, but is 6 divisible by 2? Yeah. Not so much for simplifying. We can't add or subtract. Yes, I see where you're going with that. So with the 6i, I can't add and subtract. Yes, because I think that's where you were going. Now the 4 and 6i, you're 100% correct. We can't add or subtract those. But because there is this common factor of 2 across all three, we can simplify this. And it actually simplifies out completely. Because here our 4 divided by 2 is 2. 6 divided by 2 is 3. And we still have our I. So it's 2 plus or minus 3i. And I'd say especially on the test, I'd be stepping this process out. Because if for some reason on the test, this last part, the simplification, goes awry for some reason, if you do have at least the 4 plus or minus 6i over 2, I will still take it because that is the correct answer. It just means that the simplifying, it would be next week. Because that's less of you actually using the quadratic equation to solve it and more just simplifying. But, one. Questions on this here? Analyzing the discriminant. Now the discriminant is our b squared minus 4ac. Now the discriminant can have one of three values. And that's it is either 1 greater than 0, which means that we have two real solutions, b squared minus 4ac is equal to 0, which means we have one real solution, and b squared minus 4ac is less than 0, which means we have two, I say complex solutions. We could say two imaginary solutions. Kind of the same thing. We have this here because the b squared minus 4ac is coming outside of the radical, which we have the plus or minus the positive negative case. Because if b squared minus 4ac is greater than 0, it means we can take the square root of it. It's a positive. We're fine there. But if it's less than 0, that means that whatever's inside that square root is negative. And if we have a number inside of a radical that's negative, that negative is going to come out as I. We have imaginary solutions, complex solutions. So the value of the discriminant, this b squared minus 4ac, really tells us what type of solutions we should be looking for. So, when we look at these next few here, lines down. Find the discriminant of the quadratic equation. Describe the number and type of solutions of this equation. So we're really looking for the value of b squared minus 4ac. Well, our a value, b and c, a is 1, b is negative 6, and c is 10. So if we want to find the value of the discriminant, we just plug it in. So b squared would be negative 6 squared minus 4 times our a value, which is 1, times our c value, which is 10. Questions on how we got to this part here? The next thing we would do is negative 6 squared minus 4 times 1 times 10, which is negative 4. So is our discriminant greater than 0, equal to 0, or less than 0? Less than 0, so we have 2 complex solution. That's all it is. Because really, when it says number and type, I think this is enough because we gave the number 2, and what type? Complex. For some reason, it wants us to, the book would want you to solve it, but this is all we need. We need what the discriminant is and the number and type of solutions. That's it. We ready for the next one? Now, if doing this here, it's not equal to 0, we need to get it equal to 0 for us to find A, B, C, and then be able to plug this in. Now here the value of A is, value of B is, C is 9. B squared minus 4 AC. Well, B is still negative 6 squared minus 4 times 1 times 9. And our answer is 0. So since the discriminant is equal to 0, how many solutions do we have? One real solution. Really, for this here, we could say we have one real unique solution because we technically have 2, but they're going to be the exact same solution. Questions on this here? So for the last one, A is 1, B is negative 6, C is 10 and 9, it's 8. So anybody have a guess at what the answer is going to be? 4. Because it's actually been increasing by 4 each time. Yep. So that's 2 real solutions. Yep. Yeah, because negative 6 squared is positive 36. Negative 4 times 1 is negative 4. Times 8 is negative 32. So 36 minus 32 is indeed 4. Questions on this here? Here we need to see another example of finding the discriminant number and type of solutions. We feel good with this here. We feel good with this here. And that's it. And that is technically the end of chapter 3. Well, ish. Well, there's still one more section on chapter 3 that we're going to cover, 3.7, but we're going to cover it after the test. Because the last part we're covering is nonlinear systems. So we've done systems of equations. We started the year off, we did 3 variable. You've done 2 variable in Algebra 2. But all the systems we've done so far is what we consider linear. Both equations are lines. So in 3.7, what we're going to be looking at is something like this here, where we have a quadratic and a line, and we're trying to look at where they intersect, where they cross. But that will be after the test.